Okay, so let's discuss about segmentation. So the problem that we were having is that if we have a RAM and our program is too big, we were doing contiguous memory allocation. Now the problem was that like there might not be a program might be really big, and since the programs have started becoming bigger and bigger, we cannot find contiguous memory allocation for our programs. So that was becoming a problem. So now what we do is when I write my program, the program actually, when I write my program, I don't write my program like in a sequential manner. What I do is I write different functions, and write like I use different libraries. I have a main function and stuff like that. So that is my view of how I am actually writing code. So segmentation is a similar kind of a thing, which actually takes the programmer's view and then tries to figure out how we can actually solve the problem of contiguous memory allocation. So let's say this is our code. So in our code, I will have a main function. Okay, I will have some subroutines or some functions. Okay, I will have my heap over here, and I will have my stack over here. Actually, I'll not write heap, but like I'll have my stack over here, and there'll be probably some like variables which will be declared, like let's say global variables. So there'll be variables over here. I don't like to write global variables, but that's a different topic altogether. Okay, so instead of actually taking this program and then trying to figure out the a sequential way in which we can actually arrange this and put it inside the main memory, what you do is you basically make these as different segments of your program. And each segment, so this program will basically have a segment table. Okay, so let's say this is segment 0, and this is segment 1, this is segment 2, this is segment 3, this is segment 4. So what will happen is there are segments from 0, 1, 2, 3, 4. So this is for 0, this is for 1, this is for 2, 3, and let's say 4. And there will be a limit, and there will be a base. So each of these segments of a program, so each program will have a segment table. Each program will have a segment table, and you will divide your program into different segments. So let's say segment 0 is starting from location 100, and it is of size 50. Let's say part 1, the stack actually starts from location 400, and its size is I don't know, 150. Let's say this starts at location 300, and its size 25. This starts at location 700, and it's of size 10, and this starts at location, let's say 500, and 500 will actually not work over here. Let's say this starts at location 800, and its size is 20. Okay, so what will happen is that you will write your program in your different way, and then it will be broken down into different segments. Each segment will have its base register as well as a limit register. There will be a segment table for each one of this program. So when the CPU says, earlier what was happening is the CPU was actually saying that I want line number 36 or I want line number 34. Now instead of saying that, it will say that I want a segment, let's say I want segment 3, and what I want is I want the 5th line out of it. So this is your segment number, and this is your offset. Okay, so this is your segment number, and let's say D is the offset. So first thing what program will do is it'll check is the segment 3 over here or not? So it'll figure out, yes, segment 3 is over here. It's at base register 700. Then next what it will do is it will get the limit out of it. So I will get the limit from here and check with my offset. So I'll check with my offset, can I actually go and execute the line number 5? Is this inside the limit? I will say that, okay, yes, it starts at 700 and its size is 10 and offset is 5. So yes, it is good. So I can actually execute it. So this is yes. Then what I will do is I will figure out where the base address is. So the base address is at 700. So I will add 700 plus 5. So it'll be 705. Memory location would be 705. And I will get the address from here and give the value. If my offset is actually not correct, then what I will do is there will be an address trap and the address will be wrong and then something will happen. The OS will take care of it. So what happens is, in this case, what happened is that our code broke down into different sections, and let's say the section 0 was from location 100 to 150. Okay, so this was segment 0. Okay, so segment 1 was from location 400 and it was of size 150. So this was segment 1. Segment 2 was at location 300 and its size was 25. So this was segment 3. So now what, as you can see, what is happening is that, excuse me for my horrible drawing over here, but as you can see, our program now does not need to be in contiguous memory location. It can actually be spread across the RAM. So this is our physical memory. So our program can actually be broken down. So if there are bigger programs, we can actually break them down into different segments and store them at a different location. So we are solving a problem of contiguous memory by doing segmentation. There will be a problem in this. There will definitely be external fragmentation, but the thing is that the size of your program actually is smaller, so we can actually fit smaller sections inside these smaller holes. There will still be external fragmentation, but we don't have the requirement that we have to save entire program in contiguous memory allocation. So that becomes a little bit easier. There is definitely an overhead over here where the CPU will actually tell what is my segment number and what is the offset. So it has to go there and figure out the actual physical address of it.